Hi folks, my name is Chuck Black. You are in the class entitled 52 Weeks of Python. In this course, I will be teaching you to become not just somebody who can copy and paste stuff off of a web page, but somebody who actually knows how to write software. So you will become a software developer, a programmer, a coder, whatever you'd like to call it, over the course of 52 weeks. Now, as I've mentioned before, my intention in this class is that I will teach you using two mechanisms. The first mechanism and the first part of every class or every video will be me going through some code that's very easy and simple to understand, little small, digestible and understandable pieces of software. But I will also be walking you through this actual semi-product, proof of concept or whatever, that I have created that is doing the stuff that we've been looking at a little bit beforehand. This is an example of some of the output of the stuff that I've done. You can see in this example, whoa, there's no data for the course of about 4 hours. That's because I had this particular server offline during that time. So I'll be showing you different aspects about how I built this, and hopefully you'll be able to build this at the end of our time together. Let me get that out of the way. Now, before I get too far into this, I wanted to show you something, and that is what my normal development environment looks like. So in order to do that, I'm going to put my screen back into the normal mode that I work in. Okay, so here we are. This is the way that I normally have my screen set up. I have as many things as possible on a single screen. This allows me to do things like run software, examine the output while I'm examining code, or sometimes I have two pieces of software set next to each other, and then I can examine the two different pieces of software at the same time, etc. This is in general how most software developers do things, but for the purposes of our class, we're going to be making the text much bigger so you can see it, so it's a lot easier to follow what I'm going through. So I'm going to put it back to the way that it was at the start. Okay, so as I mentioned, I'm going to be going through first these training exercises where I'm going to walk through code and show you exactly what I've done. As you can see, I'm dealing with devices, teaching you how to use functions, teaching you a little bit about parsing strings intelligently, how to print things, dealing with multiple nested loops to do stuff. I'm going to be comparing lists versus dictionaries. I'll teach you a little bit about enums. We'll be going over everything is an object. That's something that's true in Python. And as you get more and more advanced, you're going to need to understand this. And the last thing that I'm going to talk about in this basics section is I'm going to teach you about list comprehensions, which you will see people using. They can be very confusing at the beginning. So that's what I'm going to do, and the intention of this class is to go at a fairly brisk pace through a lot of the more basic stuff, but I do understand that some of you have just started with your learning how to do networking, and so what I'm going to do instead at the very, very beginning is I'm going to go over some stuff just to give you a little bit of background about how to do stuff. If you're very experienced, you may not have to watch this, but you can watch it as well. There may be some things that will be of interest to you. So what I'm going to do is I'm going to begin writing some code and then modifying the code. And in the process of doing this, teach you about strings and variables and lists and dictionaries and for loops and stuff like that, just as an introductory level, and also printing. So I'm going to write some code. I'll speed it up so you don't have to watch me do it, and then I'll talk about what I just wrote. Okay, so just really quickly, this is pretty simple. The thing on the left-hand side of the equals sign, that's going to be a variable. A variable can point at different types of data. You can change your variable however you want. I can, after I've said name equals Chuck, if you're familiar with any level of software development in other programming languages, you'll say, okay, well, that's a string because it's in quotes. I can come in here and say name equals 1, which doesn't make any sense. But name is just something that points at an object, and now it points at an actual integer object. So in Python, data typing is dynamic. That is, it gets assigned to a data type at the point that you give it a particular value. So at this point in time right here, name is equal to a string, and at this point in time, name has now been changed to point at an object, which is actually an integer. But that doesn't make any sense, so let me move on a little bit more and give you another example of some of the basics of Python. Okay, so let me show you what I've just done here. This is another thing that's important. Here we learned about variables. Here we're looking at print statements. Pretty simple, easy to read. That's one of the nice things about Python. I'm printing out this constant string, which says my name is, and then I have a comma, and then I have this variable name. So my variable name is Chuck in this situation. As you can see, the output says my name is Chuck. Now, if I change this to the value David, then I ran this program, then what you can see is now it has printed out my name is David. So that's a print statement, and it's also using variables to represent stuff. But just having a name is pretty simple and not all that interesting. So I'm going to make this exercise a little bit more interesting by giving us a little bit more information when it comes to not only one name, but having multiple names. Okay, so let's continue here. Now, it's just having one name is not all that interesting. Maybe we want to have more than one name. And the way that we do that is we put it into a data structure that in Python is called a list. You may have seen this in other programming languages or in JSON or in other data representations as an array or a vector. In Python, we call it a list. Lists are sequences of items that are ordered. Now, when I say ordered, what that means is that things, once they are put in a particular order, they remain in that order. It does not mean that they are sorted. It means that they are ordered. Now, I'm clicking right here. This is one of the nice things about having an IDE is you can not only notice this thing right here in the purple or mauve, that is a built-in function that I can use. You'll notice that my string literals are in green. That's pretty handy. Variables as well as these operators like an assignment statement are just in white, and you'll see other stuff. When I come in here and I click at the beginning of a particular item like a bracket, this is a square bracket, then it nicely highlights for me the ending bracket over here on the other side. So this is one of the nice things that you get when you use an IDE. Now, if I'm going to create a list, I will be using square brackets. So on the right-hand side of an equal sign, if you see square brackets, you will know that it is a list. And in our situation, it's a list of these four things, these four names that I have, as it turns out: David, Chuck, Peter, and Jane. And if I were to just print this out, notice this doesn't really make sense. It says my name is. What if I change this to say the names are? And I run this. Another nice thing is I'm able to just run things quite easily, and I can see the output of this. The names are these four different names. So I've moved up a little bit in terms of intelligence and what I can do. Not only do I know a little bit about print statements and about variables, I know that there are types of variables that can be pointing to a different type of data structure called a list in Python. And here I'm printing them all out, and that looks pretty handy. But this isn't probably the best way. What if I had 20 different names? That wouldn't really look too good. So let me introduce you to something else in Python that makes this a little bit more useful. Okay, so what I've done here is I've introduced a control statement. This is really important. The things that we tend to use in Python are going to be two things. Number one, we will be using variables. Number two, we will be using control statements to control our execution. In this situation, I'm doing a for loop, and if you've seen for loops in other situations, they're typically pretty messy. This is one of the nicest things about Python, is that it's very easy to do for loops. If the item in question happens to be iterable, that means you can iterate over it, then you can do a for loop as simple as this. And what this says is for every name in this piece of data, this variable, which is a list called names, I want you to do the following things, the following thing in our situation. And as you can see, it has actually printed out all of these different things 4 different times. So it looped through here 4 different times, and every time it printed out this constant, the current name is, and every time name had a different value. It should be David, Chuck, Peter, and Jane. And if I look over here, the first time it was David, Chuck, Peter, and Jane. Remember I said that lists were ordered? It keeps them in the same order. That's an important thing to be aware of. So now you know a little bit about lists. You know a little bit about looping and the way that you're going to be writing code that actually does something in this Python programming language. So when we talk about individuals, their name is one piece of data. That's not all there is going to be about that particular individual. So what I'm going to do is I'm going to make this a little bit more robust and print it out a little bit and print it out so that we can look at something that's a little bit more advanced piece of software. So let me get started with that. Okay, so let's look at our example. We've made it a little bit more interesting because now not only do we have names of individual, but these individuals have multiple attributes. And so what we've done is we've represented some of the attributes. I've said the name of the person is David. You can kind of see by looking at this, name is David, location is UK, handsome, of course, is true, stunningly handsome, I would say, and intelligent, maybe, okay? And then for this other individual, which would be name is Chuck, location is California, handsome, I think my wife would probably agree, is false, intelligent, probably the people that I'd work with would might even say false, but I'm going to use a string here and say the jury is still out. If I was to print this out, I can do the same thing because notice, what's this? It's a square bracket. That means that this is a list, and I'm going to explain about the curly brackets in just a minute. Now, if I run this, as I mentioned, I can look here and I can see, all right, well, it printed all this stuff out. The current person is, and then here's the information about that person that it printed out, and here's the next one. So that's all good. Let me look a little bit into this and we can look in more detail. Here, I say that the first person is this one that's listed right here in this data structure, and the second one is right there. Now, they are enclosed in these curly brackets. What is the curly bracket? In Python, curly brackets, if you have 2 items separated by a colon, see if I can speak correctly. If it's separated by a colon, that would be this thing. Then on the left, you have the key. On the right, you have the value. This is going to be a dictionary. A dictionary is an unordered collection of key value items. So here's the key, location, the value is the UK, key, handsome. This, oh look, this is different. It doesn't have quotes around it. There are built-in values for Booleans that would be either true or false. You can do special things with those. These are all keys and values, and these are dictionaries. This is how you would print out that type of information. Now, the last thing that I want to show you here is this. I want to change how we're printing stuff out so that we can do it a little bit more intelligently with later versions of Python. If I put an F in front of this string right here, that means that this is a formatted string. And what I can then do is I can put inside curly brackets. It's a special type of character that's used for many things. I can print the actual variable that I want to print out. So I don't have to worry about organizing my print statement in fancy ways. This is very handy for printing stuff out. And if I've done this correctly, then you can see the output looks exactly the same. Hang on just a second. This curly bracket, does that have anything to do with this curly bracket over here? The answer is no, those are entirely different. This curly bracket is saying the value that comes inside the curly brackets is going to be a variable that I want you to print out. This curly bracket is saying, hey, the next thing that's coming is going to be a dictionary with key value pairs. And when I said that it's going to print out the value that's associated with the variable person, then here's the value that is printing out. Oh, that curly bracket is representing that this is a dictionary. Okay, so hopefully that background Python stuff makes sense to you. Things like variables and lists and dictionaries and loops and printing stuff. We'll be doing that throughout this course. We'll be using it over and over and over again. So hopefully that makes sense. Now, at this point, I'm going to transition into giving you a little bit of background about this Quokka project that I've been talking about and that we looked at the output for last time as well as at the beginning of this time. So I just want to give you a brief high-level overview of what it is all about. Before we go into that, in case you were wondering what a Quokka was, this is what a Quokka looks like. This is either a Quokka or it is David Bombal before he's had his cup of coffee in the morning and a shave. I'm not sure which it is. Quokkas can be found, I think, on Rottnest Island off of the western coast of Australia. They're very cute. You can look them up, but that's not what we're talking about. What we're talking about is this project. This is a high-level architectural view of the thing that I built. Now, before you step back and go, whoa, 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 this is way more involved than I'm ready to bite off or to get involved in. Let me tell you that there's a very small amount of code that I've written for this Flask piece of the code. The REST API pretty much comes for free. Node.js runs and I just provide a little bit of JavaScript stuff. Communicating with the devices we do through Napalm. Communicating with the database we do through SQL Alchemy. So the amount of code that I've written is significantly small, and as I've said before, I'm going to go to the next page here. Everything should be made as simple as possible, but no simpler. And my motto when I try to build things is definitely to make it as simple as possible. So let me talk about these pieces really quick so you have a high-level overview. Flask. What is Flask? Flask is an application server framework that provides for you the opportunity to write software that is going to run inside an application server. It will receive REST API requests. That is, these are going to be web requests that come in from wherever, and then you can write code that will service those requests. Now, what we do in this particular project in Quokka is we service those requests by either going to the database, by going out to devices or hosts or services, and then returning information to the user interface that is asked. Getting things to and from the database is extremely simple. We will be using classes that we haven't defined yet. This is something that we will learn about, but it's only a dozen lines of code or so for every table that we're storing in the database. So every piece of information, whether that be about devices or hosts or services, or even, those pretty graphs that I showed you, I'm keeping time series data in tables as well. That's all stored very simple with a couple of lines of code, and I will make it easy for you to understand. And so that is how we'll be operating in terms of communicating with the database, in terms of communicating with the devices. You may have heard of or be familiar with Napalm, NetMiko. You certainly know what it's like to communicate, to actually use the CLI on devices. We'll be using that quite often. Depending on how this course goes, we may also use netconf to communicate with devices. I may even throw in some SNMP as well. But it's pretty simple. The point that I'm trying to make is that there are boatloads of code that has already been written that we get to utilize, such that the amount of code that we have to write is extremely small. I'll give you a peek at some of the code that we'll be using right now. I've separated using a common design pattern in building software. I've organized my code into model, view, and controller type packages and a type of structure. It's a common pattern. The idea of model is that is where the database stuff. So as you might not be surprised, we have a table for devices, we have a table for hosts, we have a table for services. Remember I mentioned time series data. This is the time series data for devices. This is for hosts. This is for services. Let's just take a peek and see how complicated this is. When I go to my host database, look at that. What is that? 16 lines of code, and probably 6 of them are blank lines just for readability. So there's not a whole lot of code involved in that. Now this is the models that we've defined. There will be a lot more that we go into, the APIs to communicate with the models, etc. But we will go into that at a later point in time. The controller, let me just give you an overview of that. You can see here I have threads that I'm using to do all of this monitoring. So just a reminder of the data that we are storing. We have devices, but in a compliance type view. We have hosts that we can look at. We have services that we can look at, and we have events that we can look at. Now, each one of these will allow us to look at the data for a particular point in time. And remember, for devices, I'm keeping response time. This is going out to the cloud and actually trying to establish a connection. So it's not like a ping response time, but it is how long it takes for me to establish an SSH connection with a device that is far away in the cloud somewhere. This is my CPU utilization, availability, memory utilization, etc. These are the things that I'm keeping track of, and we're storing them here in the database, as I mentioned. Now, how am I storing all of this stuff, and how am I retrieving it? Well, I've got various tasks that I launch and that run in the background. I've got a compliance task, I've got a device monitoring task, I've got a task that's going out and discovering devices in my local network, I've got a task that's going out and monitoring the hosts, monitoring services. I'm building an hourly summaries so that you can do things like service level agreements. And I have a manager that allows me to bring up and down these particular threads, tasks that I'm going to be starting. And lastly, I just wanted to show you, these are my views. They're all pretty simple. So like if I wanted to get my device time series information, this is all the code that exists in order to get my time series information. I get the device name from the request. I get how many data points are required. Once I've determined that it's given me a correct device and one that I can get, then I go out and I have this API that says get me the device time series data, and I pass in the device name and the number of data points. And when I go down to that particular piece of code, this piece of code is going to go to the database, and I am going to make a database request where I'm filtering based on the device ID. I am limiting it to the number of data points, so that typically is 24, and I'm ordering it by descending on the timestamp. This is all I have to do in order to get this data out of the database that is going to be serving up device time series data that we're looking at right here. So that's what Quokka is all about. Hopefully that makes a little bit of sense. As we go through this course, I'm going to be explaining to you little bits and pieces of the code so that you'll understand it. And so with every class, every video that I do, I will be doing part of it, talking about the code that we looked at earlier for the first half, and then the second part, we'll be looking at a piece of Quokka. Hope that makes sense. Thank you for listening. This has been fun, and I'll see you next time.